The 747-400's 16 main landing gear wheels are unmistakable. Other than such a large number of wheels, there is much more going on behind the scenes. Imagine, if you will, for a moment, the tremendous amount of pressure the landing gear take on, not only on landing, but for braking action as well. As was mentioned, the 747-400 has 16 main wheels and a 2-wheel nose unit. 4 trucks of gear hold 4 wheels apiece. These main gear consist of 2 body gear trucks and 2 wing gear trucks. Body gear and nose wheel retraction and extension is handled by the number 1 hydraulic system, while System 4 provides power for the wing gear. Alternate extension is also available. Landing gear retraction and extension is handled normally by the gear handle. By use of the air-ground sensing system, the gear knows when it is and isn't in the air by monitoring the tilt of the main gear. When in the air, the gear tilts. Tilt sensors detect this and know exactly when the aircraft is in the air. On the ground, the gear lever is locked down by use of the sensor system. The sensor system also provides other functions for other systems. When the landing gear lever is moved into the up position, retraction begins and automatic braking action occurs to stop the wheels. The main gear doors then open and the main gear tilt to the retract position. On the ICAS, the indications change from that of a down and green to a white crosshatch, which means the gear are in transit. Following retraction, the main gear are held by up locks. The nose gear is mechanically up-locked. By then placing the landing gear lever in the off position, this depressurizes the system. I see pilots forget this step quite a bit. If there is a problem in the retraction, the ICAS gear indication will change to a non-normal, more detailed format and will show the affected gear. When commanded in the down position with the landing gear lever, the doors open, the gear is unlocked, and the proper indications are shown on the ICAS. The landing gear essentially free falls by use of gravity to the down position, where they are downlocked using hydraulic power. The doors are retracted using hydraulic power. Like the retraction, if there are any abnormalities, the abnormal gear indications will show on the ICAS. Alternate gear extension can also be activated using the alternate gear extend switches. The gear door latches and up locks then release and allow for the gear to fall under gravity and air loads. Springs then pull the down locks into place, locking the gear down. Nose wheel and body gear steering is provided. Hydraulic system number 1 powers this steering. A tiller bar for each pilot provides low-speed steering with great maneuverability. With the tiller bar, the nose wheel can be turned either direction up to 70 degrees. The rudder is less maneuverable, as it can turn the nose wheel only 7 degrees in each direction. The tiller bar overrides any rudder input. A unique feature of the 747-400 is its ability to turn the actual body gear in order to achieve greater low-speed maneuverability. In essence, the body gear turns anytime the aircraft is 15 knots or below, and the nose wheel is at 20 degrees or more. When the speed increases through 20 knots, the body gear then centers and the body steering is disabled. A great deal goes into the steering of the aircraft, but all that is useless without brakes. The brake system is quite complex, so let there be no delay in getting to it. Each main gear wheel has multiple disc carbon brakes. These brakes were designed to take an astounding amount of punishment. The brake system includes the following components: normal brake hydraulic system, alternate reserve brake hydraulic system, brake accumulator, anti-skid protection, auto brake system, and the parking brake. Now each of these in detail. The normal brake hydraulic system is powered by hydraulic system 4. The brake pedals operate their respective side brakes independently. The alternate brake hydraulic system takes over in the event system 4 pressure becomes low. This system is run by hydraulic system 1. If systems 4 and 1 become low in pressure, system 2 will power the alternate brakes system. Loss of systems 4, 2, and 1 will cause the brake source light to illuminate. The brake accumulator provides for parking brake application. Anti-skid protection is provided for normal and alternate hydraulic brake systems. Each individual main gear is provided anti-skid protection by its normal hydraulic system, while the alternate system provides anti-skid protection in wheel tandems. When a skid is detected on a wheel, brake pressure is reduced in order to stop the skid. In addition to the normal anti-skid protection, hydroplaning and touchdown protection is provided using inertial ground speed. Locked wheel protection is also available by comparing wheel speed with other wheels. Brake torque limiters are also present in each wheel. If an excess amount of torque is detected in the wheel, action is taken and the brake pressure is released. This feature is very important in order to prevent serious damage to the landing gear. The auto brake system is a very important portion of the braking. Various levels of automatic braking are available for landing, as well as full braking for ejected takeoff. This system is operational only under normal brake system functionality. The anti-skid protection system also provides anti-skid protection during auto brake operation. The RTO function of the auto brakes provides maximum braking when on the ground, speed is above 85 knots, and throttles are closed. If any one of these three criteria are broken, the auto brakes will not activate and the pilot must use manual and less effective braking action. For landing, 5 levels of deceleration are available. In order for auto brakes to engage after landing, the following must occur. All thrust levers must be closed. Ground mode is sensed, and the wheels have spun up. Speed brakes and reverse thrust also contribute to deceleration of the aircraft, and based on their use, they directly affect the workload that the auto brakes take. The auto brake system will disarm anytime one of the following happens. Pedal braking applied, any thrust lever advancement after landing, speed brake lever moved to the down detent after the speed brakes have been deployed on the ground, disarm or off position selected on auto brake selector, auto brake fault, normal anti-skid system fault, loss of normal brake hydraulic pressure. Anytime the auto brakes disarm, the auto brake switch will turn to the disarm position. By turning the selector off, power is removed from the auto brake system. After takeoff, the selector will switch to off after being in RTO. The parking brake can be operated by either the normal or alternate hydraulic system. If either of these becomes unavailable, the parking brake can be provided pressure with the brake accumulator. Accumulator pressure is seen on the brake accumulator pressure indicator. The accumulator only provides enough pressure to park and hold the aircraft and should not be used for stopping the aircraft. The parking brake is set by pressing in both brake pedals and simultaneously pulling up the parking brake lever. This locks the pedals and commands the parking brake valve to close. Depressing the pedals will release the parking brake lever. Like the hydraulic system, we will cover the synoptics page for the gear. Brake temperature is shown in the middle of each wheel at a range of 0 to 9. A white number is normal and an amber is a high range number. Gear door indications are seen as cross-hatched as not closed, full white when closed, and not present when the indications are in-op. What an amazing system the landing gear is. It takes so much wear and tear and still performs many functions, and all the while gives you a great amount of backup.